Hi everybody, welcome to my class. Okay, today I will cover a little more complicated sequence. Okay, let's read the questions. What is the sum of 40 terms of the following sequence? Okay, the sequence starts like that. 2, 3, 5, 9, 18, and 37. So whenever we have a sequence, we have to check with the increment to find the pattern. Okay, 2, 3, 5, 9, 18. Increase by 1, increase by 2, increase by 4, increase by 9. This is not fixed value. So we have to analyze one more step. So let's call this a primary sequence, and this one is a subsequence, level 1, subsequence. Subsequence here, increase by 1, increase by 2, increase by 5, increase by 10. This is not fixed value. So let's call this one a second subsequence. Okay, we analyze this one again here. Increase by 1, increase by 3, increase by 5. Okay, this one we just rewrite. This is not fixed value again. Then we have to analyze again. So we just write down here 1, 3, 5, 7, and increase by 2 to 2. It's a fixed value. Let's call this one is third subsequence. Okay, once we have a fixed value, then we can handle this one using arithmetic sequence formula. Okay. Okay, keep in mind this one. Now, third subsequence, first value was 1, increment was 2, so general term will be 1 plus 2 times n minus 1. If you expand and simplify, we will get 2n minus 1. Once we have a general term, you just put the sigma notation to get sum. So this was a sum formula, sigma quantity 2k minus 1. Okay, now let's use distribution property. Then it will come out. Okay, to save time, I just keep the expression itself. Okay, now, a third subsequence, general term of third subsequence, first value plus sum of increment here. Okay, but only one less term. Okay, sum over one less term. So 1 plus 2 times sigma k with one less term. And then here, 1, you don't have a k, then you just multiply, so minus n minus 1. Now, you replace this one by formula. The formula was n times n plus 1 divided by 2, but in place of n, we replace n minus 1. So n minus 1. n plus 1 becomes n. So n minus 1 times n over 2. Now, 2 and 2 cancel. You have 1 here. So this one will come out n squared minus 2n. Okay? N squared minus cancel and cancel. N squared minus n. And you have here and 1 again. If you simplify, you will get n squared minus 2n plus 2. Okay? This one is a general term of a third subsequence. N squared minus 2n plus 2. Okay? Remember this one, n squared minus 2n plus 2. Once we have a general term, we just need to put the sigma notation to get the sum. So, sum of a third subsequence would be sigma k squared minus 2k plus 2. Okay? And again, to save time, we just replace it here. Just write down. Okay? Now, second subsequence given by first value plus the sum of increments, but one less term. Okay? So first value was 1, and this one expand and simplify, come out this one. Okay? At this point, stop your video and work out on separate paper by yourself and compare. Okay? But I cannot go over every single one, just like a simple algebra 1 stuff, right? Expand and then replace and simplify. I think that everybody can do it. Okay? When you come to this advanced level arithmetic sequence, then, okay, this simplified to here. Once we have a general term, you can get sum by using sigma notation. So into this general term, you just put the sigma notation, then you will get sum. Okay. Okay. This time we work out 1/3 sigma k cube, and then 2/3 sigma k squared, 19/6 sigma k minus n. Okay. After you replace the formula and simplify, come out this one. Okay, come out this one. This one is a sum of a first subsequence. Sum of a first subsequence. Then we can get general term of a primary sequence. Okay, remember this one, 1, 4, 11, 4. Okay, with that we check. We made a mistake or not. Okay, 60, 16. It's okay. So this one is no problem. Now, when you get general term, we put here first value plus, in place of n, you replace n minus 1 to the fourth, 4, n minus 1 cube, 11, n minus 1 square, and 4 times n minus 1. Once you don't have a k, you just multiply out, right? And divide by 12. And then you expand all of this one and simplify on your paper and compare with that. Compare with that. Okay? When I work out, come out this. So once we have a general term, you just put sigma notation again to get sum. Now, 1/12 put outside according to distribution property. And sigma k n to the 4th minus n cubed, 29n squared, and 34n 36. Actually, I made a mistake here. I have to replace by k, 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 k. Okay, you replace it here yourself. K, 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 because you hear k. Okay. After you work out, if you simplify, you will get 1/120 n times the quantity 2n to the 4th, 15n third, 60 times n squared minus 45n plus 238. Okay? This one is some formula. Now we check with the case of 4. Okay, we replace n by 4. Then 4, 2 times 4 to the 4th, 15 times 4 third, 60 times 4 squared, 45 times 4, and 238. The answer come out 19. Okay? Actually, you write down 4 terms, 2, 3, 5, 9. Okay? If you don't remember primary sequence, stop here, you go back at the beginning on your video. Then you can see. Thus, this formula is verified and acceptable. Okay, but to save time, I check only with one case. Now we can get sum over 40 terms by replacing the value of n in S. So a n by 40 as shown below. So you replace n by 40 and 40 and 40 and 40 and 40, and you calculate. The answer come out 1,418,150. This one is sum. Okay? It's a more complicated problem. We handled it. Now, again, I emphasize you memorize this one. Sigma k squared n times n plus 1 times 2n plus 1 divided by 6. Sigma k cubed n times n plus 1 divided by 2 whole value, you square again. Now, sigma k to the fourth. And okay, last time I showed you how to derive sigma k squared and sigma k to the third power. And using same method, you can derive a formula. Okay? Okay. For more practice, go to my website. Okay, this one. Pretty much all the time, every single lecture, I show you my website address. Okay. Okay, thank you for your watching my video. Okay, see you next time with a different topic again. Bye.